Hello interwebs. Welcome to my first video. Today we will discuss an instrument I created using the Graphic User Interface Programming Language, MaxMSP. The instrument is titled Superimposition. What is meant by this title? The verb superimpose means to layer one or more things on top of one another, typically so that both are still evident. The superimposition occurring in this patch is a type of frequency modulation called multiple carrier FM. In this patch, the orange panels are all part of the multiple carrier frequency modulator. In multiple carrier FM, two or more carrier signals have their phase offset modified by a single modulating frequency here. Let's play with the patch. There are 5 presets: the 3 carrier frequencies, the modulating frequency, and the modulation depth. Let us load some presets, or values for these numbers. Select the read message in the purple panel. No, not over there, purple panel. You stupid human interface. It's connected to the pattern storage object. Good. Now, choose a file of saved presets. If you have no saved presets, you can store your own by choosing integers connected to the store $1 message. I'll set the presets to a few numbers. Then I will choose the integer 13 and click the store $1 message. Careful not to scroll up and down this integer object, or it will replace your loaded presets. Now we will recall preset 1 by selecting 1 in the integer object connected to the recall $1 message. Now when I scroll back up to 13, we see that the presets I stored have been reset. It remembers. You may store as many presets as you want. Now, enter presentation mode. The multiple carrier frequency modulation is not an end in itself. In this patch, one of 3 input signals from the ADC, a sound file, or a sine wave, is multiplied by the resultant signal of the 3 respective carrier signals after they have been frequency shifted. If the modulating frequency in the FM is set at or close to 0, we get ring modulation of the input source by the 3 carriers. The 3 carrier signals have the option of being tuned to a Pythagorean chromatic scale, ratios for which can be seen in the sub-patch. There is a trigger to the right of the picture slider to turn off or turn on the Pythagorean relationship. The carriers can also be manipulated manually. Let's listen to how the patch sounds modulating a simple sine wave. Toggle the trigger next to the cycle object in the reddish panel and adjust to a frequency of your choice. Turn on the DAC and adjust the rightmost gain. When you turn on the dock, also turn on the trigger next to it. Notice as I scroll through the integers connected to the recall $1 message in the purple panel, the modulating frequency and modulation depth, along with the 3 carrier frequency, all change. As we scroll through various presets, we can see how the Pythagorean tuning is used by adjusting the gray picture slider. With some presets, it is less evident than others, and at values close to 1. In the carrier frequencies, we hear a rhythmic relationship rather than a pitch relationship, due to the tremolo created by the ring modulation of the incoming signal. Now let us try a sound file, rather than a sine wave. Toggle the trigger in the red panel off, and toggle the trigger to the left of the SF play object in the green panel. Open the sound file with the open message in the green panel. We will use this reading as our sound file, to be just a bit more meta. Ha ha ha. Lols. Or is that redundant? Never mind. Now, Click the Loop 1 message, and toggle the SF Play object to begin reading the sound file to be sent to the modulator. Today we will discuss an instrument I created using the graphic user interface stored in the language XMST. The instrument is titled Superimposition. What is meant by this title? The verb superimpose means to layer when a remote feeds on top of one another, typically so that both are still evident. The superimposition occurring in this patch is a type of frequency regulation called multiple KUFM. Doesn't that sound nice? This patch has been written with live instrumental performance in mind. One participant plays an instrument into a microphone, and another manipulates this patch manually. The delay lines are adjustable for optimal interaction of the live performer with the processed audio, or they can be used as filters at lower levels of the tap-out objects. Let's play with them a bit and see how that sounds. We will continue to use the sound file to avoid feedback. Presets. Now we will recall preset 1 by selecting 1 in the integer object connected to the recall $1 message. Now when I scroll back up, we see that the presets I stored have been reset. It remembers. You may store as many presets as you want. Now, when using this patch with live performers, be sure to either use an external mic or connect to external speakers to avoid resonance or feedback. It has been my pleasure to communicate with you today. I hope the rest of your browsing on the interwebs goes well. See you next cycle.